Assalamualaikum warahmatullahi wabarakatuh. Today, we would like to present about our project. Let me introduce to you my group member. First, Ahmad Syabir bin Muhammad Fuad, Muhammad Syahmi bin Samsudin, Muhammad Shazwi bin Muhammad Zaki, Aziz Zafran bin Zurul Kafli, and lastly, Safiuddin Ramzi Ali bin Shukri. So we go through the introduction. Introduction is, what is soil? Soil is a complete mixture of living organism, organic matter, mineral, water, and air. Soil also can be divided into sand, clay, silt, peat, chalk, and loam type based on the size of the particle. The characteristic as a soil, it is with a low shear strength, highly compressible, and low permeability. The soil also in a condition in insufficient bearing capacity, excessive post-construction settlement, and instability on excavation and embankment forming. For the settlement problem, it can be defined as a deformation in the soil due to the applied stress. So, the topic of our project is challenge in construction over soft soil. Soft soil is a quaternary sediment consists of alluvial deposit and organic or peat soil. This soft soil can be found mostly at west coast and east coast of Peninsula and East Malaysia. For soft soil, many failure can be related to height settlement and deformation and mostly have been reported. So the solution on the ground improvement is to make the soil become more stable. Thus, the construction can be done within the time frame. Soft soil is not the best place for the construction to build on.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syabir bin Muhammad Fuad. Okay, now I want to present about the case study for our project. Okay, the challenges in construction of soil. Most of the engineering problem in the form of slow instability, bearing capacity failure, or excessive settlement could occur either during or after the construction phase due to low shear strength and high compressibility of the soil. Our location for our project is at Hospital Tengku Ampuan Rahimah Integration Quarters in Klang, Selangor. And the location is experienced instability of the ground during construction work and had caused some amendment in terms of time and cost in completion of the project in Selangor. The soft soil in Malaysia is deposit of clay, silt, and sand, and also namely as organic or peat soil. So the case study in Klang, Selangor is categorized in west coast of Peninsula Malaysia according to Quaternary Geological Map of Malaysia. Next, for our project background, the Hospital Tengku Ampuan Rahimah in Klang, Selangor was started in 2007, and the site is underlined by very soft to soft silly on the range of 15 to 20 meter, and the next layer of medium stiff to stiff silty clay, while the hard stratum is subsequently found at the depth of 18 to 28 meter. The 500 mm diameter concrete span pile with design capacity of 850 kN has been proposed as foundation system for the building. However, there was no ground treatment work proposed by the design consultant to improve the engineering behavior of soft soil at the site. So the construction problem is the installation of pipe was started overground right after site clearing. So unfortunately, because we are working with soil and other hidden feature in earth, there is an element of the unknown and things that do not always go as planned with a driving concrete, steel or wood piles. are common. Piles were in this cross-section. Most of the installed piles were found to be deviated from original position after some time. Conclusion that we can get from the problematic soil that occur throughout this construction process is: first, piles are driving out of alignment. Next, the blow count is above pile penetration requirement. Soil analysis should accurately predict the number of blows required to drive a pile to its planned depth, and if the number of blows is substantially higher than expected, it indicates a problem with either the driving system, the soil, or both. Next is the problem of pile deviation was also expected to be caused by the blow count for bearing pile rapidly for the pile position. That's all from me. Thank you.
Application for soft soil. The technique used to compact soil in situ is dynamic vibro-grouting and surcharging. Surcharging is the best suited for soft soil that will experience excessive settlement under a structural load. This method places soil fill on site to pre-consolidated existing soil prior to construction, and it helps to improve soil via compression, increasing stiffness and shear strength. A vertical drain are placed to surcharge placement, which accelerate drainage and reduce surcharge time. Typically, 1,000-foot long rolls of drain are fed into a mandrel, which is pushed, vibrated, driven, or jetted vertically into ground through a mass mount to a backhoe or crane. And then, dump truck is used to transfer fill soil, utilized for preloading, and dozers are then used to push the soil into the mound. Second application is reinforcement. This method of improvement involves constructing a reinforcing element within the soil mass that does not change the soil properties. The procedure of this application starts with column construction at the bottom of the treatment depth, in which can extend to depth of 100 feet and proceed to the surface. The vibrator initially penetrates the ground with assistance from each weight. Vibration at the weight jets in this stage. Then the vibrator is raised several feet and the stone falls around the vibrofloat to rotate, filling the cavity that has been formed. The vibrator is repeatedly raised and lowered in this fashion, compacting and displacing the stone in 2 or 3 foot deep. Lastly, the flushing water is directed to a settlement pond where suspended and soil fineness settle.
Hello, my name is Muhammad Shahmi bin Samsudin and my metric card number is AF10070. Today I will like to continue our group application and I will cover the topic of fixation. Soil fixation is commonly achieved via permeation grouting, jet grouting or soil mixing. This bind soil particles increasing the soil strength while reducing its compressibility and permeability. For jet grouting, it is effective across a range of soils and represents a bottom-up process. This technique serves as an alternative to conventional grouting, chemical grouting, slurry trenching, underpinning, or the use of compressed air or freezing in tunneling. Commonly used to provide excavation support of an existing structure before an adjacent site is excavated to make way for a new deeper structure. Another method which is most applicable in soft soil is soil mixing. This process is used in a host of general civil works projects to provide excavation, tunneling, and foundation support. And as for the procedure in using of jet grouting, we first need to drill a grout hole of 100 to 150 mm diameter, and the hole is kept stable by using water circulation. And then we need to jetting commences in the horizontal direction through nozzles in 2 to 4 mm in diameter at the tip of the monitor that is rotated at 5 to 30 revolutions per minute. The soil cutting travel to the ground surface through the annular space between the borehole and the monitor. And lastly, the monitor is lifted at a rate of 50 to 300 mm per minute in the third step, resulting in the formulation of a grouted column. And that's all from me. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Shazri bin Muhammad Zaki. My metric number AF180052. From our research data, we can finalize that soft soil is known to be able to withstand excess weight of its own, and the additional burden will result in significant deformation. The systematic preventive and remedial action should be taken to ensure that these problems can be mitigated and eventually resolved. It is evident from this study that the compacting and reinforcement system by means of the mandrel, which is a vertical drain and vertical column installation, attempted to resolve this problem. However, the compacted soil has a decreased rate of water absorption and drainage. This occurs because large pores transfer water down the soil more efficiently than smaller pores. This occurs because large pores transfer water down the soil more. In addition, gas exchange slows down in compacted soil, contributing to an increase in the probability of aeration-related problems. The study also found that soil filtration can be accomplished by jet grading, which is capable of enhancing the efficiency of soil treatment and lead to a sustainable method of remediation.